All right, what we're going to do is to go over Test 8, Chapter 8, Form A, and Form B, similar questions, same answers, just have to spot where they are. So remember, you are to show your work, and this is more or less what the work would look like. For number 1, determine the number of real number solutions of the equation from the given graph. Well, this is finding the zeros. This is your quadratic equation. It's a parabola, and it crosses the x-axis at -3 right there, and at 2. So there are 2 places where it crosses the x-axis. So all they're asking is, how many real number solutions do we have? 2. And there's our answer. Now, for number 2, they want us to, I guess we have the work up here, so we'll leave it this showing. They want us to use the principle of square root to solve this. So if we take the square root of this side, as we indicate here, and the square root of the other side, this just becomes then the radicand, and plus or minus the square root of that is 9. We transpose the 17, get a -17, plus or minus 9. -17 and a -9 is a -26, and -17 plus 9 gives us an 8. So there are our 2 answers right here. Now for number 3, the same thing. We're going to take the square root of this side, plus or minus the square root of that side, which is what I'm showing here, already partially worked out. We transpose the -5 to the other side, becomes a +5, and we get this as our answer. Now notice in the multiple choice, as they want you to do it in Math Lab, they are writing the answer twice. One the positive value, one the negative value. And notice they're putting the 5 after the radical. That's okay. I tend to put it before. All right, number 4, again, it's in function notation. We're saying this equals 12. So take the square root of this, it becomes the radicand, and plus or minus the square root of 12. Now you might recall the square root of 12 is the square root of 4 times the square root of 3. Square root of 4 is 2. That's where I get our answers for number 4. All right, let's go on. Now here for this number 5, they're asking us to complete the square. This is part of a trinomial. We want to figure out what do we put in this C term here to make this a perfect square trinomial. Well, we take half of 18, and I told you about the technique of putting a parenthesis. Put the square root of that there. Half of your B term, which is 9. Now you square 9, and you get 81. So this would be the form of the perfect square trinomial that if you factored this, would factor into that. And that happens to be letter A. So the strategy we taught as we went along was to take the C term, bring it over to the other side as a -33, put a set of parentheses with a square out there, take the square root of our first term, which is A, take half of what B is, which is 7, square 7, and get 49. Then we factor that perfect square trinomial to this, but remember, to keep the whole thing equal, we had to put the 49 on the other side as well. So we add these two together and we get 16. So then when we take the square root of this side and the plus or minus square root of 16, remember square root of 16 is 4, we bring that 7 over to the other side as a negative 7 plus or minus 4. So negative 7, negative 4, that's negative 11. And negative 7 plus 4 is negative 3, right there. Now, I didn't pick out the hardest of these to do. There's plenty of technique involved, and there are a couple of hard ones later on. So again, there's our basic equation. It's in standard form. We transpose the 5 to the other side as a negative 5. We then take half of 10 and get 5. Now, we needed to add a 5 squared to this side, which was 25, to make it a perfect square trinomial. So we have to add the 25 to the other side. So we add the negative 5 and the 25, get a 20. Take the square root then of both sides. We get x equals, after we transpose the 5, a negative 5 plus or minus the square root of 20. Now you might recall from chapter 7, the square root of 20 is the square root of 4 times the square root of 5. Square root of 4 is 2, and that's where I get my answers. And they've written it twice. Now, for number 8, again, they want us to complete the square to find the x-intercepts of the functions given by the equation listed. Okay. Well, we will equal this expression to 0, putting it in standard form, and then bring the positive 49 over to the other side as a negative 49. Take half of our b term, that gives us an 8. So we have to square the 8 to get our new c term, which is 64. So we had to add 64 to both sides. And then I subtracted 49 from 64, got 15. Took the square root of both sides, transposed the positive 8 to the other side, got a negative 8. There are our answers. Now, these are our x values. What will our y values be? 0. So that's how they're giving the answer. This is 1, comma 0. This is the other point, comma 0. Remember, this is a parabola that's going through your x-axis at these x values, but since they're x-intercepts, your y value is a 0. Now, as we do these others, there is a protocol. We must have it in standard form. Why? So that we can get our value of A, our value of B, our value of C, so we could put them in the quadratic formula, which I have written out here. I'm sure you have it in your notes. Now remember, we had to transpose that C to the other side, change its sign. That's where we get a positive 3 equals 0. Then we substitute this into the quadratic formula, and that will give us our answer. Now, what I've done for all of these is actually I have the work on another paper, which is right here. So once you've identified the b, remember it's negative b, so a positive 8 goes in there as negative 8. Plus or minus, you're going to square the 8, minus 4 times a, which was 3, times c, which is 3. This gives you a 9 times 4, a negative 36, and a positive 64 gives you a positive 28. And then this is 2 times 3, which is 6. And then I simplified 28 is the square root of 4 times the square root of 7. The square root of 4 is 2. And then I just simplified this. Now the answer on your answer sheet has this all over 3, which is another way to write it. This way is good too. Number 10, again, you had to identify, and I've worked it all out here for you. Square root of 84 is the square root of 4 times the square root of 21. Square root of 4 is 2. So again, we simplify, and the answer on the page is all over 4 here. Number 11, that one was sort of easy, wasn't a lot to do, and I left it all over 2. Again, you have to identify the A, the B, and the C to put it into the quadratic formula. And for all of these, this is how it's done. All right, there is 12. Now, interestingly, in your test paper, they have this answer. They left it all over 6. I would also accept this. You could reduce the negative 3 over 6 to a negative 1/2. This way is okay as well. Now, for number 13 and 14, they wanted you to deal with the discriminant, and the discriminant is just what is under the radical sign. And you recall, if you get a whole number under the radical sign, that is, that it's positive, and here it happens to be a perfect square, so this will give you, in your answer, 2 rational solutions, just by looking at what's under the discriminant, or what is the discriminant. Plug A, B, and C in there, and if it's a perfect square, you get 2 rational solutions. Now for 14, when we did that, we got an irrational number. You might recall that this is going to end up being 2 up over here, the square root of 21. So the square root of 21 is irrational, so you get 2 irrational solutions. Now, if this were a negative under the radical sign, you would have ended up with 2 complex numbers, or 2 imaginary solutions, again, relating to chapter 7. Let's go back to look at what we've done. So here A was 1, B is 3, and C is negative 4. We put them under the radical sign to see what kind of results it would give us. Since it was a 25, we knew we would get 2 rational answers. Here because this is the square root of 84, it's not a perfect square. You're going to get two irrational answers. Now for number 15 and 16, they're asking if these are our answers, what were the equations that led to them? Okay, so with that in mind, let's look now at what we had. Well, the answers were a positive 3 and a positive 6. So we are working backwards. We put it in its factored form. We then FOIL this, and we got this. 16, the same thing. Put it in its factored form because x equals 0. That was one of the solutions. This was x equals a negative 1, x equals a 3. Then we FOIL this, then distributed the x, and there's our answer to number 16. All right, in number 17, I remember it well. So we had one person and another person working together. They can get the job done in 6 hours. This is actually related to chapter 6. So we know one person takes 9 hours longer to do the job than the other. So this is the person who gets their regular job done. That's that person's rate. The other person is 1 over x plus 9. Takes 9 hours more to do the job. Working together, they get the job done in 6 hours. Okay? So what do we do here? Well, we have to get rid of the fractions. Again, this is chapter 6 stuff. We have an rational equation. So we multiply each term by the lowest common denominator, which is our x plus 9, and 6. So that when we do that, here the x will cancel out, and we get x. Well, the x up here will cancel out. We go 6 times this, 6x plus 54. Now here the x plus 9 cancels out, so we're only left with 6x. Here the 6 cancels out, and we're left with x squared plus 9x. So we have a quadratic equation. How do we solve it? Well, we group like terms. 12x plus 54 equals this. I want to keep my x squared positive, so I move everything over to the other side. I get this. I factor it, because it factors nicely. I get x is a negative 6, or x is a 9. Now, since you don't have negative 6 hours to do a job, we reject that, so our answer is 9, and that's the answer. That would be what x is. The other person would take 18 hours to do the job. But together, they get the job done in 6 hours. The beauty of algebra. Now, number 18, as we look at it, again, let's take a look at it here. Here we have Bill can row a boat 3 miles an hour in still water. If it takes 3 hours and 36 minutes to go 3 miles upstream and return, find the speed of the current. Okay, for this, we're going to use the distance formula. And we want to put, because we know the total time, so we want to find out what time is. So when we solve for time over here, we get distance divided by rate. Again, this is chapter 6. So there's the distance going downstream. He rows plus the speed of the current. Going upstream 3 miles, He rose at 3 minus the speed of the current, and it equals to this. Now I can't have hours and minutes, so I have to convert everything to hours, which is 3 3/5 hours that I've made into an improper fraction. 5 times 3 is 15, plus 3 is 18 over 5. Now, what is my common denominator? Well, it's 3 plus c, 3 minus c, and a 5, which I have listed all over here. And then I cancel this out, and I have the rest of it multiplied. Cancel this out, multiplied. Cancel the 5 out, and I go 18 times. Notice these are conjugates that I can just FOIL and get this. So I then notice that here the negative 15c and positive 15c cancels out. I add 45 and 45 and get 90. I want to keep everything, well, at least my c squared term, positive. So I bring that over, and I end up, after I subtract 162 from my 90, I get a negative 72. And this one worked out really nicely because the 18s cancel out nicely, and I get c squared minus 4 equals 0, which is the difference of perfect squares. That factors into its conjugates, and I have c is negative 2, c is positive 2. I'm going to reject the negative value, and I will say the current then is 2 miles per hour, and this checks out very well. And we just see it right there. Again, that took me a little bit of time to do, and I'm sure it's going to take you time as well. Okay, our last few examples, again, these were a little challenging. In number 19, solve for v. So I'm going to take the square root of both sides, actually, and that's what happens here. That was really an easy one. This next one is a little bit more challenging, and I've written it out over here. So red shows me my original right here. Want to get rid of my fraction 3, multiply both sides by 3. Here the 3's cancel out. Then I'm going to divide both sides by pi. And I want to get r by itself, so I take the square root of both sides, and that gives me my answer. So this one was, again, not too bad. Now this next one, I have to admit I did spend a little bit of time working on it myself, and we want to solve for m. Now notice that m initially here is in a fraction form. The m is also under the radical sign. So to get rid of the m as a fraction, I multiply both sides by m. So I then get Vm equals this. Now to get rid of the radical sign, I'm going to square both sides. So this just becomes the radicand, and I have this. Again, you might say, how am I going to get m by itself? Well, I'm going to transpose this to the other side as a negative then 2Vem. Now I have an m squared and an m. How do I solve it? Well, I'm going to use the quadratic formula. And what would my a term be here? I want to solve for m. Well, my a term is v squared. My b term is a negative 2ve. And my c term, since there isn't any, is 0. Okay, So I then put it in the quadratic formula. A negative b would make this a positive 2ve, plus or minus the square root of. Now I'm going to square this up here, and it becomes a positive 4 v squared e squared. Then I'm going to multiply a negative 4 times my v squared, which is a, times my c term, which is 0. So that makes this 0. All right, so now under the radical sign, I just have this. And this is a perfect square that comes out as 4 v squared e squared is 2ve, which is what I have up in front. Now, these two terms are exactly the same. If I subtract them, I end up with a 0. So 0 over this is 0. M could be 0. But when I put this as a positive, I get a 2ve plus 2ve gives me a 4ve. I cancel the 2 with the 4, get a 2. I take one of the v's out on top. I'm left with a v on the bottom, and I have a lowercase letter e there as well. Wow. Again, I went through this quickly. It did take me a little while, and also thinking about what's going on here to use the quadratic formula. Okay, well, I kept this to 27 minutes. Hopefully it's helpful for you.